Hi everyone, welcome back to my channel. This is Mr. Budihas, your online math teacher. In today's video, I'm gonna talk about arithmetic sequences. Let's start. Arithmetic sequence, also known as an arithmetic progression, it is a sequence where each term after the first is obtained by adding a constant called the common difference. We will be adding this common difference to the preceding term, and common difference is represented by small letter d. Example of an arithmetic sequence is 4, 8, 12, 16, and so on, and the common difference is 4. Now the question is how to get the common difference. To get the common difference, you just simply subtract second term by the first term, and that is 8 minus 4, which is 4. Next, we have the third term subtracted by the second term. 12 minus 8 is also 4. Then lastly, we have the fourth term subtracted by the third term. 16 minus 12 is also 4. Next example is -5, -2, 1, 4, and so on, in which it has a common difference of 3. Now again, to get a common difference, we just have to subtract the second term minus the first term, and that is -2 minus -5 is +3. And next, the third term subtracted by the second term, 1 minus -2 is +3. And lastly, we have fourth term subtracted by the third term. 4 minus 1 is +3. Now again, the common difference for this sequence is 3. Take note that if we don't have a common difference, then that sequence is not an arithmetic sequence. Next is we have term. Term refers to each value in a sequence. For example, the sequence 4, 8, 12, 16, and so on. 4 there is the first term, and it is represented by a sub 1. Next, we have 8, which is the second term. It is represented by a sub 2. Then a sub 3 as the third term is 12. Then the a sub 4 or the fourth term is 16. General term of a sequence. It is the formula used to find the nth term of a sequence. We have a sub n is equal to a sub 1 plus the quantity of n minus 1 times d, where a sub n is the nth term, a sub 1 is the first term, n is the number of terms or the term position, and d is the common difference. This formula is used to find the nth term of an arithmetic sequence. For example, in the sequence 4, 8, 12, 16, and so on, find the 10th term. Before we solve this problem, of course, we need to have first the 3 necessary values before we can use the formula. We need to know who is a sub 1, who is n, and who is d. A sub 1 is equal to 4 because 4 is the first term in this sequence. N is equal to 10 because we need to find the 10th term, or we care only for the 10 terms. And the common difference for this arithmetic sequence is 4. In this sequence, the 10th term can be found by substituting these values to the general formula. And we have 10th term is equal to 4 plus the quantity of 10 minus 1 times 4. Then solving first what's inside the parentheses following the PEMDAS, we have 10 minus 1 is 9. Then multiplying 9 by 4, we have 36. Next is we add 4 plus 36. The total is 40. Therefore, the 10th term is equal to 40. If you are to continue this sequence 4, 8, 12, 16, 20, 24, and so on, the 10th term is 40. Next, we have the arithmetic means. Arithmetic means are the terms between any two non-consecutive terms of an arithmetic sequence. The terms between any two non-consecutive. For example, in the sequence 4, 8, 12, 16, 8 and 12 is the two arithmetic means between 4 and 16. Now let's try some example in finding the nth term of an arithmetic sequence. Number 1. Find the 20th term in the sequence 6, 13, 20, 27, and so on. First, we need to identify the common difference of this sequence. Again, to find the common difference, you just need to subtract the second term by the first term. And we have 13 minus 6 is 7. Then the next terms, we have the third and the second. 20 minus 13 is 7. Then we have 27 minus 20 is also 7. This 7 is common, therefore this is the common difference. After that, we have to list the necessary values, the first term, the number of terms, and the common difference. We already have the common difference, which is 7. Then the first term is, in this given example, the first term is 6. Therefore, a sub 1 is 6. Then n, since we need to find the 20th term, our n is 20. Then, substituting these values in our general formula in finding the nth term of an arithmetic sequence, we have a sub 20 or 20th term is equal to 6 plus the quantity of 20 minus 1 times 7. Again, we have to solve first what's inside the parentheses by following the PEMDAS. So 20 minus 1 is 19. Then 19 times 7 is 133. Plus 6 is 139. Therefore, the 20th term is 139. Example number 2. Find the 30th term of an arithmetic sequence if the fifth term is negative 10 and the common difference is 6. To solve this problem, we need to remember the formula in finding the nth term of an arithmetic sequence so that we will be guided on what to prepare or what necessary values are we going to prepare. We have here the list of necessary values. A sub 1, we don't have yet a value. And a sub n is equal to 30 since we are to find the 30th term. And for the common difference, as stated here, is 6. And I included the a sub 5 or the fifth term, which is negative 10, so that we will be using this in finding the first term. Now, we cannot go directly finding the 30th term because we don't have the value for a sub 1. We need to find first this a sub 1 before finding the 30th term. But of course, we'll be using the fifth term, not the 30th term. We will be using the same formula in finding the first term and plugging in the necessary values. We have n is equal to 5 and a sub 5 is equal to negative 10. And for the common difference, the same. Substituting all the necessary values, we have here the fifth term is equal to a sub 1. I highlighted a sub 1 since this is the problem. Plus the quantity of 5 minus 1 times 6. Solving first, what's inside the parentheses? 5 minus 1 is 4. Then 4 times 6 is 24. Here, I change a sub 5 into negative 10 because that is the value for the fifth term. So this becomes negative 10 plus, negative 10 is equal to a sub 1 plus 24. Now, separating the variable term and the constant term, we have here, from a sub 1, it becomes negative a sub 1 since we transpose this one to the other side. And this negative 10 transposing to the right side, it becomes positive 10. And we have 24 plus 10 is 34. Now, take note, we are to find the a sub 1, not the negative 1 or the negative a sub 1. So we have to divide both sides by negative 1. So it becomes a sub 1 is equal to negative 34. Therefore, the first term is negative 34. Now we can use this a sub 1 to find the 30th term. Solve for the 30th term for the sequence using a sub 1 is equal to negative 34. So again, the same formula. The 30th term, or a sub 30, is equal to, the a sub 1 is negative 34 plus 30 minus 1 times 6. 30 minus 1 is 29, multiply it by 6, and we get 174. So we have now 30th term is equal to negative 34 plus 174. Here, since this is unlike sign, of course, we have to subtract 174 minus 34, and that becomes 140. Therefore, the 30th term is 140. And that's all for today's discussion. Now, I want you to answer this individual practice for you to check if you really understand my discussion. And please comment below your answers so that I can check also. And that's all. Thank you for watching.